Okay, so live testing is dangerous and we shouldn't be doing it. Hi, welcome back to the channel. I'm Mark from Apprentice 1-to-1 and Powersonic, and in today's video I wanted to look at some equipment that can help us carry out some of what we reference as live testing in the safest possible way. It's often said how live testing is exposing yourself to unnecessary risk and we shouldn't be doing it. We should be using calculation, and whilst I can accept that point of view for periodic inspections at times, certainly with initial verification, for me we have a process of tests that we have to work through, and the reason we work through them in the order that they're laid out in Guidance Note 3 is because of the importance of verifying each stage along the way and then having the live testing at the end to verify that connections we've interfered with and made adjustments to in the carrying out of those test procedures we've then reinstated correctly, and that we have a valid and viable live earth path and live tested polarity. So it's unavoidable for me as regards initial verification, but I think we can make improvements to do it more safely. We don't need to be probing onto every connection and exposing live terminals unnecessarily. Some of it is avoidable due to the innovation of manufacturers' products, and I've got a few of them here that we utilise and use, and I want to run through some of them in today's video and demonstrate some of them in use so you can see exactly what I mean. We've always had the principle of maintaining safety whilst carrying out live testing by trying to limit access to live parts. So there's been some valid points raised around PPE that's used whilst accessing live terminals, and that always needs to be based on a risk assessment to the task you're actually doing. There's no one-size-fits-all approach for that. So I couldn't stand here and say you must wear this, you must use this, but there are some basic principles that we do need to follow for any what we would term live working. And of course, if you can remove the live working aspect by not exposing live terminals, then that is always the safest way. Now in this video I'm not going to reference any safe isolation or locking off. I've been through that in other videos already. So when I am exposed to terminals on this board and I say that they're isolated from the supply, they are correctly isolated from the supply. This is actually really easy on the test board, and I've said on lots of the other videos we're assuming this is a live and working installation, but it is just on a plug top. I can safely remove it and we know that the entire thing is disconnected from any source of electrical energy. But getting straight on to looking at some of these products, I'll run through left to right if you like. So as we said already, we've got the Lockout Kit, so if you are turning the power off anywhere, opening circuit breakers, make sure you do lock them off and that they can't be interfered with by somebody else. We've then got safety glasses, so I mean it doesn't hurt to wear these for any kind of task when you're out on site. I don't wear them in these videos because I like to try and get across the message that I'm delivering, and can be a bit distracting, just my personal choice. But if you are working on any live electrical systems, always helps to have a good set of safety glasses on. These ones are from Klein, not paid or sponsored in any way, but we do use them. And again, other basics, so your VDE tools, again, just last line of defence. If you're tightening down on terminals, they shouldn't be energised. There is no reason to be working live ever, so you shouldn't have any reason to be pushing screwdrivers into terminals to tighten them up whilst they do have electrical energy present. But if there was to be a mistake somewhere, and mistakes do happen, ensuring you're using VDE tools are a good last line of defence. Whoops. Equally, these, for if you're inside a consumer unit, these are VDE all the way down the handles and to the prongs, so you've got that total protection. These are actually really good. They're made by Nipex, and you can get a nice solid grip on most conductors at the back of consumer units and accessories. And again, whilst you shouldn't be in there with live parts exposed, it doesn't hurt to use these just in case. And again, if there was to be any live conductors inside an enclosure, you're not going to be shorting out between them with metal prong pliers. So we always use these inside electrical accessories. And again, torches. So these are my Unilight ones, and you've seen me show these on videos before. So this is the SLR 1750, really bright, and it also doubles up as a battery bank. So if you're changing a consumer unit, for example, and you need a good light source while you're doing it, this is ideal because you can keep your phone topped up as well. And alongside this one with the Bluetooth speaker, so you can have some music on or a podcast or whatever while you're working away. Always nice to have. Bit of, yeah, I mean, you need to be able to see what you're doing, don't you? Basics, and you need to be able to make the day pass without it being a laborious, boring nonsense, because otherwise you're going to lose concentration and focus. So I always find I work better with a bit of background music or something else going on around my work site. The other one, and you've seen me show this before, is the TIS 859 voltage indicator. So you can use that as part of your safe isolation process, and it's got the all-important GS38 probes on the end. So if you are exposing yourself to live parts, and there will be times where it's unavoidable, such as when you're taking a ZE or a PFC measurement or testing RCDs, for example, you will need GS38 probes. So there is those. We've got your proving unit as well. So that's to prove that your instruments work after safe isolation or through the course of safe isolation. Wander lead right at the end, so if you're measuring R2, that's always with the enclosure covers in place, so it's quite a safe way of checking that there is earth continuity around the electrical system. That's a 50 metre one, I think it's a Q-Tech one, that one, but we have them from various manufacturers. You can get them from TIS, Mega, Q-Tech, loads of other manufacturers do them as well. There is also these Q-Tech lamp holders. Now these are a bit marmitey, some people either love them or hate them. I really like them, certainly if you're doing a lot of domestic EICRs, because you can get these into, I mean that's a bayonet one, there is your GU10 holder and such like, you've got your E27s, so I mean the basic principle is, and this one's the Lightmate SES, so the basic principle is you would put your line and your neutral probes into this while it's in the light fitting itself, and then you just need to probe onto an earth connection, and you can take that ZS measurement, you know, reasonably safely using those, because you're not exposing any live terminals. So if you've got a class 1 electrical fitting, you have no reason to really go opening it up and exposing yourself to live parts. You can insert that into the lamp holder, make a connection to earth, and carry out that measurement. And if anything, it proves the earth path in a user's best way, because it's actually connected onto the physical metalwork of the accessory rather than the earth terminal, because that's the point of contact they're going to be making with the electrical system. So they're really, really handy. When you're testing at pendants, again, if you're exposing those live terminals to carry out a Z test, and on initial verification, for me, that test needs to be made. So you would be at the final point in the circuit. You can insert the bayonet lamp holder into the pendant. Demonstrate that on there actually, if you can see this, pop that out of the way. So it would go in like that. You can put your probes in, expose the earth terminal within here, and you've just got one single probe then onto the earth terminal, and that's a reasonably safe method of doing it if you're using your other appropriate PPE, your experience, knowledge and training, to carry out that as safely as possible. One thing I've skipped past actually is this here. This is the TIS clamp meter. So again, if you're looking for earth leakage and things like that, you can carry out that test without exposing anything. You can just clamp that around conductors, and it'll give you an idea of what's going on with the flow of electricity within an installation. So that's always a handy test to make before you delve too deep into things. And that can often be the case when you're fault finding. I've said this before about when you're doing fault finding with heating systems, for example. There is an element of that which needs electrical energy to make the system operate, so you can fault find effectively. But you can also do that by utilising stuff like clamp meters, voltage indicators, without exposing yourself to live terminals. So whilst there is electrical energy in the system, if you can, keep it enclosed, keep yourself safe for as long as possible. But ultimately, you need to find that fault, and you're the person with the skill, training and experience to do it, so carry out as safely as you can. One of the new things that I've just started using is this from Q-Tech. So you'll all have seen these where it's you plug that into a socket outlet, you can put your probes in and take your measurements, but they've now made this one with a fly lead, and I've seen people with homemade versions of this where it's just an extension lead that you can wire into a fuse spare, for example, and then you can use your plug-in adapter to get a reading of ZS. And the basic idea of this is you could connect it onto a commando socket, for example, and you can insert it into your blue 16 amp 32 amp commando socket outlet and get a measurement of your ZS from that point without having to expose the terminals to carry it out. And another useful feature of it, and it does involve interfering with electrical connections still, so you need to be careful with that when you are reinstating those connections after carrying out your test. But you can carry out safe isolation, make sure that the electrical system's de-energized, and you could wire this in, for example, to a fuse spare outlet whilst the electricity is off, and then you can restore power and carry out that ZS measurement from the spare with this wired into the circuit. So I mean, for example, this fire alarm panel, rather than exposing the live parts within the spare, you could wire that into it for the short duration of carrying out a ZS test from the final point in the circuit. And then you've got you still would have to reconnect the fire alarm panel, so you would have to ensure that you are ensuring polarity is correct onto that. It's not foolproof, but it is a way of getting a ZS measurement at the end of a circuit without exposing yourself to any live parts. And again, you could do that with a pendant cord drop, so you could remove the lamp holder, wire that into the pendant itself, and then you've just got probed connections in to get your ZS measurement. And in that case, you're making a connection of the lamp holder being reinstated to the pendant accessory in a domestic premises. And whilst they're not polarity sensitive, they are colour coded, so you would have to ensure that you made the appropriate connection in restoring the pendant cord to its ceiling rose base. You could also do this for many other accessories. So if you've got a boiler wiring centre, for example, you can insert this into the wiring centre, wire it in, obviously taking account of other connected equipment, and get a ZS measurement from there. I just think it's a way of avoiding exposing yourself to live terminals. And you would have seen me carrying out a ZS measurement on this emergency light fitting, for example, the other week, and I'd have to get a bit Heath Robinson with it because I physically couldn't sort the camera out, sort holding the probes out, and push the test button. Now if I'd used this, I could have put this through the gland hole we've got in the side here. You can't see it on camera, but there is a gland in there, an old light fitting we've finished from somewhere else. So we could wire that the gland hole and then push terminal connections in there. So it's all push fit, some spare ones in the actual holder itself. Wouldn't be interfering with any existing electrical connections, and carry out the Z measurement if this end of ZS measurement if this end of looking in safely. So I think it's really, really important what we can that we do those measurements of ZS. You can also utilise something like this to carry out your Rcd testing as well. I mean, really, if you're following the guidance, the outgoing terminals of RCBOs and RCDs is the place that you should make that test. But there's nothing that prohibits you doing it from elsewhere in the installation. All you've got to do is prove that it operates within the required time. So I mean, you could do it from a socket outlet, you could do it from a lighting accessory, you could even, it's more laborious, but you could wire this into a consumer unit and carry out the RCD test from that way of doing it. I mean, if you've got a board loaded with a load of RCBOs, you're going to be interfering with that many connections, and it would take that long. I would say that that's not the smartest solution to that particular problem. But it is an option if you wanted to go down that road. So I guess it's that fine line. As electricians, we're there to ensure that persons and livestock are safe from electrocution and fire, and to do that we have to work with good skill and methods in our installation and design works, but also with our commissioning and our testing. So we have to utilise our experience, our training, our knowledge to ensure that electrical systems are safe for people to use. That's the purpose of the exercise. And with initial verification, we have that chain of tests based on that. So we go through the live tests to ensure the electrical system is as safe as possible, and then we carry out the dead test. We carry out the live tests after that to verify that terminations that we might have been interfering with through the process of that testing haven't resulted in an issue. We've verified our earth path under live conditions when a system is energised. We've verified that our protective devices such as RCDs are operating as they should. So it is an important process. And with EICRs, we still carry out as a business ZS testing at final points on circuits. We don't calculate, so some people would say you can take a PFC and ZE measurement at the board, and that's as much as you would need to expose yourself to live terminals. But we would utilise some of these accessories that manufacturers have provided to get those ZS measurements at the end of circuits, because at the end of the day, you know, that's how the system is going to be used by operatives. And whilst you can calculate, and it's called calculation in the loosest terms, because we need to remember when you're measuring your R1 and R2, that is a measurement. When you're measuring your ZE and PFC, it's a measurement under live working conditions still, but it's a measurement. And then combining that information into a figure for ZS isn't just calculation. And obviously it won't pan out with what is actually measured. So that's the other factor to remember, that when you are doing a bit of magic with the maths there, it's not accurate. So there is an element of needing to do these live tests. But as I said, not in a way that you're exposing yourself to live parts if it's all avoidable. You know, I'm quite happy as an electrician to probe into live terminals. I have no issue with that at all. I've been doing it for 20 years now. We have the appropriate test leads and guidance to use those voltage indicators and test instruments with your GS38 probes onto live terminals. But that doesn't necessarily mean that I should do that every time just because I feel comfortable doing it, if there's no need to. So if I can use one of these adapters and work in a safer way, then why not? It just takes an extra couple of minutes here and there to connect them in. If I can use these push-in adapters, for example, why not? You know, it saves being up your steps trying to hold 3 probes into terminals and push a test button, doesn't it? If you can make things easier and safer, then that's what we should all be doing, for me. And if you haven't seen it already, and it's different but relevant, if you haven't seen Louise Taggart's story about her brother Michael, I recommend you go and check that out. Unfortunately, he lost his life when he ended up working on an electrical system that was still live when he was led to believe that it wasn't. I'm not going to give the full details of that story because Louise tells it in a way that does it justice, basically. I don't want to stand here and waffle away about that myself, but go and check it out, because it is really, really important at the end of the day that we all go home safe and well, and we should be working as safely as possible to ensure that we go back to our families after every shift. And if taking a bit more time with equipment it's been made dead and then connecting in accessories that can help us reduce our access to live terminals is the way we do that, then that's what we should all be doing. Under the times when we are working live, we need to make sure that we're using appropriate PPE, that we are keeping a safe distance from those terminations. So don't be, for example, placing your skin in direct contact with electrical accessories when you're carrying out your live tests. Try and ensure that your probes are in good working order and that you are being mindful and careful in making those connections. It's always better to think something out twice and take your time with it than just dive straight in and make a mistake. There's never any rush with carrying out live testing. And some people will say there is a distinction between live working and live testing. And I'm kind of in between the two chains of thoughts on that one. Because any exposure to live terminals is, under the electricity it works at live testing. And we know that if it's avoidable in any other circumstance to not be working live, we should be doing that. So it's really, it's a tricky one to cover all of the basis of what's needed without falling foul of a rule somewhere and exposing yourself to danger. But we do also need to be mindful that working out on the DNO supply network, for example, there's still cable jointers out in the ground digging holes and working on live cables every day. And yes, they have the protective boots and gloves and all of their training and their VDE tools, but they're still there around live conductors all of the time carrying out their job, because that's unavoidable as far as we're led to believe. So this, sometimes when we've got to carry out live tests, certainly through initial verification, to verify electrical safety within a system that's been handed over to users, we need to make sure that we are competent, we are trained, we have the relevant experience and knowledge to carry out those tests as safely as possible. And if you haven't been given any of those things through your training, through your working life so far, then you shouldn't be interfering with live terminations of any sort. You need to make sure that you've had that through an apprenticeship or whatever other training method you're going through, you have the relevant experience and knowledge, and if you can avoid it, you must avoid it. So that's enough waffling away there about the testing. One of the other things I did forget to mention, this is a new one for me, it's from TIS. So this is the Socket Polarity Loop Rcd checker, and it's the TIS 1005. And this is actually quite good for if you're trying to find out what's connected to what. So you'll see there it does a polarity check first off, and we're getting the lights illuminating, and it actually has here an indication of the earth fault loop impedance. So you've got a red light would illuminate that says urgently check, an amber one that says check, and a green one that says good. Now it's just a visual aid, so you know that there is an earth connection to that socket outlet. You can't rely on that obviously for providing any test results, but while you're working on a particular bit of equipment, it's a good start point. I use it for domestic EICRs in particular, so you can plug that in, you've got the audible turn. Sometimes consumer units aren't labelled up in the best way, so you can go through the breakers, and when you find the right one, the audible turn stops. So if you're counting up your sockets on a circuit, for example, it's pretty handy to help you figure out what's connected where. And also one of the other features it has, if the board's not labelled up in the best way, and for example you need to add a socket on to this particular outlet, you need an extra socket, you can trip the RCBO off if it happens to have an RCBO in the circuit with the RCD test button. You see it operates there's no RCBO on this, so I've just turned the power off to the whole thing. But if you was lucky enough to have that, it would help you identify the circuit. So again, with all of these accessories, they're there to help you. So with something like this, it can't help you verify that a system is electrical safe. It's not going to give you test results you can enter on your test sheet. It's not going to ensure that the system is safe for use, but it's a good visual indicator, a good starting point. And it's all about that method of work. So again, work to your method statement and your risk assessment, follow it strictly, and ultimately it all comes back to this, your multifunction tester, and getting the valid test results you need from an electrical system to ensure it's safe for use. So yeah, kind of waffled on a bit on that one, but I wanted to get over the point that we do have all of this stuff available, and there's loads more. This is just the tip of the iceberg I've managed to grab out of my bag that's here in the unit today. We have loads of this gear that's used all of the time, and it's all about ensuring safety while you're exposed to live terminals. So anyway, drop in the comments what you think is acceptable. Should we be carrying out ZS measurements, RCD tests, or should everything be by inquiry and calculation, even for initial verification? If you think I'm wrong, then tell me. I have no issue with being wrong about things. It's all about learning, both myself and other people. All of these videos I'm putting out there are in no way intended as training, or this is something you should be doing at all times. It's just my experience and knowledge dropped into a video for people to feedback if they think it's a load of nonsense, or if they think it sounds sensible, or if some of this stuff is new to you and you wasn't aware you could even grab hold of it, even better. Just to promote that thought, if you like, that we all need to do better with our own safety. Some of the best toolbox talks I've seen is when they get you to imagine that it's a family member who's carrying out that test. So for example, if it was my son, and my son actually does work for me, but my son or daughter who was coming to work, and their boss had asked them to stick a new socket in, but we can't have the power off because it's too inconvenient, and they were given VDE tools to go off and do it. There is no way in hell they would let them do it. But if that same question was asked to you and it was your own safety, sometimes we can be a bit blasé with it and just wanting to get the task done. It's easy to run away with yourself without pausing to think, are you complying with the RAMs? Are you actually complying with the legal requirements? And are you ensuring that you're giving yourself the best chance of going home safe and well after every shift? So make sure you do value your own safety and put that thought in your mind. Question people when they're asking you to do things that you don't feel comfortable doing, that you think aren't correct. Never just go ahead with it because your boss has told you. A good employer will welcome people questioning risk assessments and method statements and ensuring that they're working in a safe manner. Because at the event of an incident and people get involved after the fact, living with the consequences of something terrible happening, and also the fines that come through the health and safety executive after that are huge, and nobody would want to have that in their lives going forward. So somebody raising an irritating or awkward question that helps avoid all of that has got to be a good thing. So it's a pretty serious video, and I don't want it to sound like a lecture or that I know better than everybody else. It's just an issue that I think is important and we all need to do more and do better with. And certainly from seeing the views on my videos, I know that the ones out on site, seeing installation works and consumer units going in and rewires and whatnot, always draw more views than the ones on the test board or the ones talking about tools and equipment, and that's fine. But ultimately these are the ones that I think are important and the people watching might get the most value from, and that's the intention of my YouTube channel. But anyway, thank you for watching, and I hope you enjoyed that. I will actually just wire this into this spare and show you a live measurement of ZS in a safe way. And again, I'm not going to show safe isolation or going through that process because we've done it before. But it's been done. We'll get this wired in and we'll take a ZS measurement. Just give me a second. ISO live testing is dangerous. We shouldn't be doing it. It's live working. It's exposing yourself to unnecessary risk, and we should just calculate everything. Now that's an opinion of some people that I don't share. I think there are safe ways we can carry out live testing, and we should be utilising those where possible to reduce the risk. But as the rest of this video has shown, I think there is a way we can do it and ensure our own safety. And in this particular way, you'll see here I have got exposed live terminals there, but I don't need to have my hands anywhere near them. I've made those connections whilst it was dead and locked off. I have now got my probes connected into the Q-Tech lamp holder, and I have got the earth crop clip on the earth connection within the pendant bayonet lamp holder. And you can see there's power running through the fire alarm panel because the neon's illuminated. I don't know if you can see the TIS MFT Pro from all the way over there, but we've got 242 volts between line and neutral and between line and earth. If I hit the test button, so again, I've got no access to these live terminals myself, just holding the test set. We've got it on the no trip measurement because, as you'll see, there's a few RCDs in this. So again, that would depend on what your installation is in front of you, but it's carry out that measurement. So I've got a Z between line and neutral of 0.67 and ZS live protective earth of 0.85. And that kind of tallies in with some of the measurements we've taken on this test board before. So if you see that there, and again, I haven't had my hands anywhere near the bitey stuff, and I could be wearing gloves and my glasses to further reduce that risk. Right, so you'll see I've put this back together now. So again, isolate the circuit, remove the connections, pop it back together, put the lamp back in to ensure that it's operating. You've done your functional test. That's that one complete. I've not been exposed to any live terminations other than having it open whilst carrying out the test, but I haven't had my hands anywhere near it at any times, and I think that's a reasonably safe way of working to carry out a ZS measurement on a lighting circuit. But if you wanted, you could wire this in to a ceiling rose and have the pendant cap cover all of those connections and carry out in an even safer manner. But just for this demonstration, we've got this Q-Tech, and it is the Q-Tech R2FL. It's very similar to the plug-in variant, but with this one, it has the fly lead, which I've connected into the outgoing terminals of the fuse connection unit. We've now got this turned on, and we have got voltage between line and neutral and line and earth. And if I carry out that test now for ZS again, it's just carrying that out. I've got no exposure to any live terminals. This is screwed back. It's just as the installation would be while users are operating it. And again, whilst you're carrying out your live ZS test, you do need to be mindful of other people in the electrical installation and be mindful of exactly what you're touching. So this is finished, it's test now. But you don't really want to be exposing yourself to skin-to-skin contact with electrical accessories. And you'll see here we've got a measurement on the fuse connection unit, and it's 0.31 ohms and 0.31 line and N and 0.75 lines protective earth. and again that's due to the size of conductors in the circuit. And yeah, that's a safe way, or as safe as possible way, of getting a value of ZS without exposing yourself to live terminations. So if some people are saying it's not necessary because it's too much of a risk due to the electricity works regulations, and there will be times where that's unavoidable because you can't get adapters and connectors into great big panels and main intakes to do those tests. A lot of it is avoidable, and the excuse of live working doesn't wash with me for initial verification 100%, because I think we can get those tests, certainly in 99% of domestic scenarios especially, without exposing ourselves as testers to any live terminals. Now, of course, there will be live terminals within the consumer unit when we are carrying out the measurements for your ZE and your PFC, and again you can obtain those values by inquiry, and we all know what they will be generally given as. But again, as a qualified and experienced electrician, it's an important measurement to take, and really you should be measuring it using your PPE, following the RAMs and making sure you've got your GS38 probes. And where you can, if equipment from manufacturers has been developed and produced to help you work in a safe manner to carry out those tests, then use them. And certainly in some big commercial installations I see now, you get a socket outlet that's very, very close to the main intake position, and some people will use that to get a value of ZE and PFC, and they're not exposing themselves to any live conductors in doing that. And obviously you need to isolate the installation, make sure it's not in use. You need to remove any parallel earths while you're getting your ZE measurement, reinstate them again against while the installation is isolated, and get your measurement of PFC. So it is a bit of a faff and a farce, but it does remove having to hold probes onto live terminals. So, you know, that is a method that some people use. Myself, I'm quite comfortable probing onto those terminals to carry out that test whilst wearing appropriate PPE. And again, you'll see me in my videos, and this is just a conscious decision of mine, that I think I look a bit of a wally with my glasses on camera. I can't actually see very well without my glasses at close quarters. So I'm fine from a distance like this, but if I'm getting up close to terminals, for example, with a screwdriver, I can't see what I'm doing without my glasses. So I would always be wearing them anyway whilst out on site working. So make sure you do wear your safety glasses, wear a pair of gloves, a pair of boots that have insulating properties. We always spec our boots as that. Get an earth mat down if you in a plant room, for example. They should be laid down anyway, but if you've not got access to one that's already in place, get one down on the ground. Anything you can do to reduce the possibility of electricity flowing through your body, you take it, you use it. No one can ever show you on YouTube all of the different applications and practicalities of working safely and ensuring that you're doing things in the right way. It's just not possible. So I want to get that message into everybody, that value your own safety, risk assess, believe in your competency, skill and training, and don't take unnecessary risks. Anyway, I think I've waffled away for far, far too long already about something that is a bit of a taboo subject in the industry. I'm prepared to put my head above the parapet and take a load of flack for my opinions. Again, if you disagree with me, drop it in the comments. If you've got something that might help me develop my learning and knowledge, please drop it in there as well. I don't profess to know everything. I'm not the fountain of all knowledge to the whole industry, far from it. I'm here to learn with everybody else. So thank you for watching. Please like and subscribe, and I'll catch you on the next one.